Let's talk about composition of functions, which is another way to combine functions, and I think ends up being the most powerful method. So suppose you have two functions, f of x and g of x, and you want to compose g with f. What does it mean to do that? Well, what it means is you take your initial input x, and the first thing you do is you just run it through your first function, f. So if the box represented the function, you're running x through this box, and what comes out? Well, what comes out is your output, which is f of x. And now the composition step is to take your output f of x, and that becomes your new input to your g function, so that your final output of the composition is g of f of x. And that's how we do the composition. So you take your initial input x and you run it through your first function, and then you just take that output and run it through your second function, and you end up with g of f of x. And we write it as g with a little circle, then f of x. And this circle is read as composed with. G composed with f of x. So let's do an example. Let's say that f of x is x plus 1 and g of x is x squared, and we want to define a function. We'll call that new function h of x, and we'll say that's going to be g composed with f of x. So the reason we define this new function is to save us time writing it every single time. We don't have to write it as g composed with f. We'll just be able to write it as h. Well, what's the form of h of x? Well, what we do is we take x and we run it through our first function f, and then we take that output f of x and it becomes the input to the g function. So h of x is just g of f of x. Now let's write down what that actually is. f of x is x plus 1, and g of the argument is just the argument squared. And so there we have it. H of x, which is g composed with f of x, is just x plus 1 quantity squared. So we've combine these two functions to create a new function. Now really quick, let's take a look and let's say, well, what would happen if we wanted not g composed with f, but if instead we wanted f composed with g of x? Well, f composed with g of x says first you run x through the g function. That gives us x squared. Then you run that output through the f function, and f just takes your input and adds 1 to it. So f of x squared is x squared plus 1. And we see right away that f composed with g of x is not equal to g composed with f of x. So in general, composition depends on order. Right? It depends which function comes first in the composition, because if you do one first and the other second, you might get a different result compared to if you switch the order. Alright, two more quick things. First of all, what happened if I wanted to compose three functions? Let's say k composed with f composed with g. Can I do this? Can I compose more than two functions? And I sure can. All it means is first you take x and you run it through your g function. Then you take that output and you run it through your f function. And finally you take this output and you run it through your k function. So composition has no limit, I'll say. Has no limit to the number of functions involved. The number of functions involved. You can compose as many functions as you want, one after another, and you just follow this order. You do the last function in the composition first, and you just work your way backwards. Alright, so the last thing is a visual examination of what a composition would look like. So let's use our original functions, or the ones from the earlier example. Let me draw our axes here. So what we're going to do is we're going to draw f of x, we're going to draw g of x, and then we'll draw f composed with g, or g composed with f of x. So f of x, we said, was x plus 1. So what we have is a straight line with a slope of 1 that crosses the y-axis at a height of 1. That's x plus 1. And g of x, we said, was just x squared. So we have a parabola whose vertex occurs at 0, 0. Alright, so what is g composed with f of x? Well, we said that should be x plus 1 squared. Alright, and actually there's a really good applet on the College of Redwoods that will allow you to do this dynamically, and I encourage you to go to that College of Redwoods applet and look for the composition of functions. And you can put these two functions in, or you can use any other functions, and you can see dynamically what it means to run the input all the way through this composition here. We'll just do a couple points and kind of get a general idea. So first, let's look at the point, let's say x equals 1. And we want to know what's g composed with f of 1. Well, first of all, you want to take g of f of 1. Now f of 1, when x equals 1, f of x equals 2. So what we want is g of 2, which, as you know, will give you an output of 4. So g composed with f of 1 should give you an output of 4. So here's x equals 1, and here's g of f of x, which equals 4. Alright, let's look at x equals 0. Well, we want g composed with f of 0, which is g of f of 0. Well, when x equals 0, f of x equals 1. So we really want g of f of 0, which is g of 1. And g of 1 is 1. So f composed with g of 0 gives us a height of 1. Just like that. Alright. Let's see, I'll delete these so we don't run out of room. Let's look at x equals negative 1. So g composed with f of negative 1 is g of f of negative 1, which is, well, f of negative 1 is 0, and g of 0 is 0. So what we get is a point that is right here. It has a x value of negative 1 and a y value of 0. Now, if we connect these, you can take my word for it, or you can check it yourself, we're actually going to get a parabola. And what I'd like you to do is try a couple more points. Try maybe the points x equals minus 2 and x equals minus 3, and see what output values you get. So go ahead and hit pause and do that, and see what output values you get, and then we'll plot them on the graph. Okay, hopefully you've computed those two values. What we get is g composed with f of negative 2 is 1, and g composed with f of negative 3 is 4. So if you plot these values on our graph, what we get is the other side of this parabola. That. Now let's look at the formula for this parabola. Well, notice that's the function x squared shifted to the left by 1. And the formula for that, of course, is x minus negative 1 squared, which is x plus 1 squared. But wait a minute, that's exactly what we would expect, because x plus 1 quantity squared is g composed with f of x. So you can see you can actually visually analyze how composing these two functions will give you that new function.